Hello everyone, I hope you stay well and healthy during this challenging period. Okay, so now let's get into the research. My research is about testing temporal boundaries of composition in low-frequency neural oscillation. So previous findings have shown that neural response can be entrained to linguistic structures. Ding and colleagues 2016 observed cortical tracking of linguistic structure and evoked frequencies correspond to phrase and sentence level processing. What does it mean? Let's look at the figure here. So given their stimuli, each syllable is 250 milliseconds long, so we know that each phrase is 500 milliseconds long, and so one sentence is second long. So we convert this temporal information into the frequency range. We should observe the syllable level peak at 4 Hz since the syllable occurs 4 times in 1 second, and we should observe the phrasal level processing at 2 Hz since the phrase occurs twice in 1 second, and we should observe the sentence level processing at 1 Hz since a sentence occurs once in 1 second. So based on this study, I have three research questions here. So the first question is that what do those peaks mean? Are those low frequency oscillation driven by the integration of information that is proposed by oscillation based model, or the evoke response for each event that is proposed by evoke response model? So in the oscillation based model, neural oscillation represents the synchronization between the amount of information from the input and the necessary decoding time. So their model predicts that neural responses fail to track syllable information if the timing for syllable falls out of data range, that is 4 to 8 Hz. They further extended the model to the word and the phrasal level processing, that is, neural response fail to track a word and phrasal level information if the timing falls out of delta range, that is 0.5 to 3 Hz. As for the evoke responses model, Nurowski et al. 2009 observed robust temporal synchronization to the speech envelope even in the speech that has the compression ratio of 0.4. And my second question cares about the relationship between the language comprehension and delta brainwave. So the correlation between the comprehension score and the neural oscillation will be examined in this study. And my third question cares about whether the rhythmicity in speech affect the processing of composition. So in Giza 2017, they proposed delta are flexible oscillators that can track syllable regularities. And we also know that daily speech is gassy, regular, rhythmic. So in this study, we manipulated temporal property of the stimuli. So now let's look at the experimental conditions and prediction here. So I have 5 conditions in the study. The first one is regular 250 milliseconds per syllable. That means each syllable is 250 milliseconds long, which is same as the stimuli from Ding et al. And my second condition is each syllable is 200 milliseconds long, and the stimuli was compressed from the first condition, so the compression ratio is 0.8. And my third condition includes the syllable has the 100 millisecond long, and the compression ratio is 0.4 here. And I also have the semi-regular condition. This means in each sentence it has this fixed sentence rate. So the first and the third syllable were 300 millisecond long. The second and the fourth syllable were 200 millisecond long. And my last condition is irregular, so each syllable is either 300 or 200 millisecond long. And based on the oscillation-based model, they will predict we still can observe these peaks in my first and second condition, but not for my third condition, since the syllable rate falls out of theta range in my third condition, and we still can observe those peaks in my semi-regular and irregular condition if the delta oscillators are flexible to track the syllable information. And based on the evoke responses model, we still can observe those peaks here, and also in my third condition, since the compression rate is 0.4 here. But as for the regularity in speech, in their model, they didn't specifically talk about this, so I put question marks here. But based on their stimuli, because they use the natural speech as their stimuli, so I predict there are still peaks here. So an EEG experiment was conducted in the study. 27 native Mandarin speakers listened to 300 trials consisting of 10 four-syllable sentences. So they have to judge whether the trial they just heard include plausible sentence or phrase or not. For the result, I compute evoke power and the inter-trial phase coherence. And since these two show similar results, so I just plot the inter-trial phase coherence here. So as a baseline, we successfully replicate Dean's finding. So 3 peaks were observed in this condition, and also we also observed these 3 peaks in my second condition, but not for my third conditions. So it supports the oscillation-based model and suggests that delta entrainment represents the integration of information, and the sufficient decoding time is necessary for the synchronization of information. And also we can see the high accuracy of comprehension in all conditions, even in my third condition here. So it raises the possibility of the dead comprehension. And we also can observe the peaks in the semi-regular and the irregular conditions, which support that delta oscillations are flexible to accommodate rhythmicity in speech. Thank you. That's all for my presentation. If you have any question, comments, please leave your question and comment in OSF. I will respond to you soon. Thank you very much.